Today we are solving max area of an island. We are given an m cross n binary matrix grid and we have to return maximum area of an island in the grid. An island is a group of ones representing land connected four directionally, both horizontal and vertical, and we may assume all four edges of the grid are surrounded by water. In this example, all four edges of the grid are water, and an island is a group of ones over here. As you can see, there are 6 highlighted islands. And out of these 6 islands, we have to find an island with the maximum area. In other words, we have to find an island that has maximum number of ones. How would we solve this problem? The hint here is that the cells of the island are connected four directionally. If we consider the cell of this grid as a node in a graph, all the four directional neighbors to it are connected through edges. We can look at this whole grid as a graph. In this graph, anytime we find a node or a cell with the value of 1, we can do depth first search from that cell and explore all the nodes or cells in that island. Once we have explored all the neighbors of a cell, we mark that cell as visited by changing the value of the cell to 0 so that we don't repeat DFS on that cell again. And we continue this for all the other cells in the grid. While we are doing depth first search in an island, we also count the number of ones in that island and return that. In this process, for each island we discover, we compare it to the maximum area of the islands we have found so far and update the maximum if we found a new island that's bigger. And finally, we return the area of the biggest island, which is the maximum area. Let's write the code for this algorithm. Let's call m and n as the dimensions of the grid. Length of the grid will be the number of rows, and length of the first row will be the number of columns. Next, we use this variable to store the maximum area of the island we have found so far, and we initialize it to 0. Next, we go through the grid from left to right and top to bottom for I in range m is the number of rows, for j in range n is the number of columns. If the grid I and j is equal to 1, that means this is an island. We do DFS from here. And this function returns the area of the island, and we update the max area if the current island's area is bigger than the area we have found so far. And then finally, we return this max area. Next, we define this DFS function. Find DFS, which takes row and a column index as input. Let's make sure these row and column indices are not out of boundary. So if row is less than 0, or column is less than 0, or row is greater than or equal to number of rows, or column is greater than or equal to number of columns, we are out of bound. Or if the grid cell is a water cell, if it's equal to 0, then we return 0 because this is not an island. If we are not out of bound and value of the cell is 1, that means this is an island. We continue DFS by exploring its neighbors. Before that, we mark this current cell as visited by changing its value to 0. Oh, these are row and column over here. Next, we explore its neighbors, that are connected four directionally. The first neighbor is to the left. We do DFS on the left neighbor, which is column -1, and then DFS to the right neighbor, which is column +1, and we go to the top neighbor, which is row -1, and bottom neighbor, which is row +1. Next, we return the area of this island, which is the summation of area of all its neighbors, which is left plus right plus top plus bottom plus 1 for the current island cell. So that's our code. Let's try to submit this code. As you can tell, the submission goes through. If you found this video to be helpful, please support by liking the video and subscribing to the channel. I will see you in the next video. Thank you.